This video is brought to you by IXL, used by millions of students worldwide to get ahead in math, English, and more.
Today we're going to find indefinite integrals involving trigonometric functions. You may remember the derivatives of all 6 trigonometric ratios. Well, we can use the same formulas in reverse to get some formulas for integrals that involve trigonometric functions. The integral of the cosine of x dx equals the sine of x plus c, where c is the constant of integration. The integral of the sine of x dx equals negative cosine of x plus a constant. The integral of the secant of x squared dx equals the tangent of x plus a constant. The integral of the cosecant of x squared dx equals negative cotangent of x plus a constant. The integral of the secant of x times the tangent of x dx equals the secant of x plus a constant. And the integral of the cosecant of x times the cotangent of x dx equals negative cosecant of x plus a constant. And sometimes we need to find an integral that happens to be in one of these forms. For example, find the indefinite integral. The integral of 2/3 times the cosecant of x squared dx. Here we can just move the coefficient outside of the integrand and apply our formula. The answer is negative 2/3 times the cotangent of x plus a constant. But very often integrals won't be in the form where we can directly apply one of these formulas. For many of these, we can rewrite the integrals using other identities we know. For example, find the indefinite integral. The integral of the tangent of x over the cosine of x dx. This time we need to rewrite the integrand in order to use one of our formulas. But where do we start? Well, none of our integral formulas have a trig function in the denominator, so let's use a reciprocal identity with the cosine of x. 1 over the cosine of x is equal to the secant of x. And now we can use our formula to integrate. The integral of the secant of x times the tangent of x dx is equal to the secant of x plus a constant. How about this one? Find the indefinite integral. The integral of the sine of x squared plus the cosine of x squared plus the tangent of x squared dx. There are a lot of squared terms here, but none that match our integral formulas. So let's see if we can apply some Pythagorean identities. Remember that the sine of x squared plus the cosine of x squared is equal to 1. So we can replace the first 2 terms with 1, leaving us with 1 plus the tangent of x squared. Hey, that's another Pythagorean identity. 1 plus the tangent of x squared is equal to the secant of x squared. Now we can use our formula for the secant of x squared dx. We get the tangent of x plus a constant. One more. Find the indefinite integral. The integral of 1 plus the cosine of x over the sine of x squared dx. This time it might be less obvious which identities can help us. So let's first just expand the fraction into 2 separate terms. 1 over the sine of x squared and the cosine of x over the sine of x squared. We can treat each of these terms separately. We can use a reciprocal identity to rewrite the first term as the cosecant of x squared. For the second term, it might be easier to split the sine of x squared into the sine of x times the sine of x. Yes, now I can see that 1 over the sine of x is just the cosecant of x, and the cosine of x over the sine of x is the cotangent of x. Now we have 2 terms that are in the same forms as 2 of our integral formulas. We can integrate each term separately. the integral of the cosecant of x squared dx is negative cotangent of x. And the integral of the cosecant of x times the cotangent of x dx is negative cosecant of x. And don't forget the constant, plus c. It may take some practice rewriting these kinds of integrals to get them into a form where you can apply a formula, but keep at it. You can do this.
Head over to IXL.com for more practice on this skill and thousands more videos in math and language arts.